Hello, you are welcome to this live class. I don't know if you are ready for this class, although they are already setting questions and want to see how far we can go this night with those questions that the people are students are sending. Now, this class, the essence of this class, I want you to know that it is not just a class, it's a class to help students, especially those of you that are writing Jamb and you are having issue in your seminar with one or two questions we can help you with. What you just need to do at this point is just to type your question and send it to us. Type your question and send it to us, and you will not have any problem by His grace. I want to start now. My name is Engineer Haliday. Where the questions that have been sent to us, we have students at the background that will be reading for us, that are also following the class live, and we have also viewers that are watching us from different parts of the nation that are Jamb students. We all know that the exam is starting by on Thursday, which have been shifted backward, and I don't know if you have one or two, but if you don't have problem, then you should be listening to people that have issues and questions that have been sent to us and learn from those questions. Now, I don't know. We want to start now. Please, can you read the first question that get to us now?
At what temperature
At what temperature? At what temperature
will the Celsius scale
would be the Celsius scale
read twice the Fahrenheit scale?
read twice what?
Fahrenheit scale.
The Fahrenheit scale. Now, this is just a question given to us first. Now, this question, now what we want to do first is to what? Scale the, what is the Celsius scale? Is what? 0 degrees Celsius. The Fahrenheit scale is, the upper fixed point is 100 degrees Celsius. I mean, this Celsius scale, the lower fixed point is 0, upper fixed point is 100. Now, please, if you have questions, you can send it to us. Now, the lower fixed point of Fahrenheit scale is what? 32 degrees Fahrenheit. Then the upper fixed point is 212 degrees Fahrenheit. Now, they said at what temperature would Celsius scale, let's say this one reach theta, reach what? Celsius scale reach twice the Fahrenheit scale. This Celsius scale will now reach 2 times the Fahrenheit scale. At what temperature would what? Theta be what? Celsius scale, this is Celsius scale, read times 2 of the what? Fahrenheit. That means that what? First of all, there will be a reading for Celsius scale, which will now read times 2 of the Fahrenheit scale. So that's why we put theta. And let's solve. If we want to solve it now, we can have theta minus 0, this one minus this, then 100 minus what? 0. That means you what? You compare this minus this. Then theta, 2 theta minus 32 all over what? 212. 212 is upper fixed point of a Fahrenheit scale minus 32. That means the fundamental interval of a Fahrenheit scale is 180. It's taken on that. Why the fundamental interval? The fundamental interval is the difference between the Fahrenheit upper fixed point and the lower fixed point. So for Celsius scale is 100. So we'll play with it. Just play. Please, let's just play with it. This one will give us what? 2 theta minus 32. This student in the house can help us to what? To press what? So that we can be fast. This one will give us what? 200 theta minus what? 320 what? 0. And 100 times this times this. Now we collect like terms. Let's bring some here. I would have 3200 equals to 200 theta minus 180 theta. 180. And what I would have now? That we're going to have what? 20 theta equal to what? 300. If I was up by 20, what do we have? This one will cancel this two. Then we're going to have it as what? 160 degrees. So that means Celsius. So at 160 degrees Celsius, Fahrenheit was K, will be twice that of Celsius K. That means Celsius K will be twice that of Fahrenheit K. Yes? The next question.
A 500-watt heater
This is another question that has been sent to us. A 500 watt heater, 500 watt heater,
is used to heat.
a 500 watt heater is used to what?
Heat 0.6 kg of water
To heat 0.6 kg of water.
from 25 degrees Celsius
From what? 25 degrees Celsius
to 100 degrees Celsius
to what? 100 degrees Celsius.
in T1 seconds.
In C1 seconds. Okay.
If another 1,000-watt heater
If another 1,000 watt heater, another 1,000 watt heater
is used to heat 0.2
is used to heat what? 0.2 kg of water.
From 10 degrees Celsius
From what? 10 degrees Celsius
to 100 degrees Celsius
to 100 degrees Celsius
in T2 seconds.
in T2 seconds.
Find C1 watt.
Find what? C1 divided by T2. Now, there is a problem here. This question is not too common. So, I mean, the person that gave us this question was very intelligent. It's not too common, but it's a Jamb question anyway. The question is a Jamb question. They set it, but it has been a while now. This kind of question came out. But let's look at how we're going to solve the question. First of all, if you want to solve calculation in physics, you have to use what they call DSS, and you have to be very smart. Now, there are two waters here involved. Let's call it water what? 1 and what? Water 2, according to the question. Now, water 1 has a power of what? That is power is what? Or rate of heat. No, but a power is something as rate of heat of what? Of 500 watts. They give us that one. And the mass of that water that is supplied with this what? That has this heater, water heater, is 0.6 kilogram. Okay? What is the change in temperature of that water, particularly? 100 minus 25 is what? Should be 75. Am I correct? Yes, 75 degrees Celsius. Then, if another water heater, let's call it one, another water heater is what? If another 1,000 watts, no, heater again, used to what? What is the mass now here for the second one? Yes, 0.2 kg. They will play with it. Change in temperature will now be what? 100 minus what? That will give us 90 degrees. Now, having gotten that, now we are looking for this. Let's call this one T2 and let's call this one T1. Now, what I want to do now is what? Power will be equal to what? MC change in theta over what? Time. Some of us are not familiar with this formula anyway. This is normal heat energy divided by time is rate of heat energy when we are talking about water heater. Then this is P1, this is T1. Now let us solve for T1. So T1 becomes what, class? MC change in temperature will divide by what? P1. So let's put the value there. So what we are going to have now is what? Mass is what? 0.6 times what? Let's say the specific capacity of water is constant, CW, because water they are giving us now, then times what? 75 over 500. Now that is T1. Let's find T2. Let's solve for T2. Don't forget the liquid involved here is water. So water is still the same thing for the what? Two of them. They have the same specific capacity. So T2 is equal to what? M02. This one is M1. Change temperature 1. This same temperature 2. So this one now MCW. Change temperature 2 over P2. Please, I will be giving you some time to write. Those of you that are watching, because this is normal live class. So probably we'll give you 1 minute or thereabout to write. Now, what is the mass for the second one? The mass is what? 0.2, Abi? Times specific capacity of water. What is change in temperature there? 90 divided by what? What is it? 1000. Now, let's play with the one. We have solved for 1 and 2. This is number 2. This is number 1 for time. But that's not what they asked us to do. They say look for what? T1 divided by T2. So what do we have now? T1 divided by what? So what do we have now, class? T1 is what? 0.6 and CW times what? 75 divided by what? 500 divide, that means T2 now, is equal to what? 0.2 CW times 90 over what? 1000. Now, what we're going to do now is to collect what? Remove the division and turn it to what? Multiplication. So what do you have now? 0.6 C times 75 over 500 times 1000, Abi, over 0.2 times CW times 90. Can we cancel out? This one cancel this one. We have 2. CW can eliminate CW because the two of them are talking about water. Then 0.21, this one give us what? 3. And so that means that 3 year 1, 3 year 30. What else do we have left remaining? Now 15 year, we have, well, 15 year 2. 15 year will give us 5 because 5 times 15 is what? 75. Then 2 year 1, 2 year 1. So our answer for that T1 over T2 is equals to 5 in ratio. It does not have units. So let's wait for them to write. 1 minute. Please, if you don't understand the question, anywhere you have any problem with, you can actually message. And if you send question, if you can solve, you can go ahead to solve. Don't wait for us, please. It will make the class very interesting to you. Once I write the question on the board, let me leave the board so that I can write. If I write the question on the board, what you are going to do for me is to solve. As they send question to us, you solve. I do my own solution, then do what they call comparison. For those of you that are just joining us, like we are on to a live class where these students contribute more to this class. That means you set your question while we answer them. You set your question while we answer them. So I think there's one other last one that was sent to us. So please, as they send the question, Mr. Sam, help us to what? To take it down, or Mr. Francis Precious and the house. Let's ensure that you will help us take down those questions. Please, this question is a very technical question and it's not too common. What many of us know more is what? H equals to LC change temperature. Yes, which is the same thing as what? Heat capacity times what? Change temperature. Don't forget the same thing is what? Is what is occurring now. Don't forget power. You should remember. In fact, once I drop this one now, you will get it. Anytime you are dealing with heat energy and all those change in temperature, it is either I square RT. Remember, ITV equals to what? V square RT, or equals to what? MC. In fact, power times time all the way equal to what? MC change in temperature, or capital letter C change temperature. Remember this formula. So sometimes they will give us current, resistance, and time. They will tell us to find heat capacity of the substance. They will give us mass. You can equate this one and this one. It's possible, depending on the parameter, you can say I square RT equal to what? MC change in temperature. You can say power times time equal to what? MC change temperature. It's from here we get this formula from. Power times time, you know that it's heat. Power times time is more or less like heat energy. So you can say ITV or IVT equal to what? MC change in temperature. Or even what? ITV is equal to IVT is equal to what? C capital letter. Don't forget there's a little thing C and small letter c. Capital letter C is what we call heat capacity, while small letter c is specific heat capacity. Specific heat capacity. Don't forget the two of them. So that is just that. Let me clean the board. Since yes, of course I will. The last question there that we have left now, for now. Then there's another one. Please help us. The last question. Let me. Please write fast if you are writing, so that we can take down another question. I think this is the second question we have had today. Calculation question always take time. That's one thing about question. So if you have not finished writing, you can send message to the group, to the our comment section. Send message to our comment section to say, oh, please, I'm still writing, so that you can see it. Yes, the next question.
An electric heater.
An electric heater.
Dipped into 500 grams. Dipped into 500.
Dipped into what?
500 grams of water.
Dipped into 500 grams of water. Into what? 500 grams of water.
In a plastic cooker.
In a what? A plastic what? Beaker.
Raise the temperature from.
Raise the temperature from
20 degrees Celsius.
From 20 degrees Celsius
to 50 degrees Celsius.
To 50 degrees Celsius.
In 3 minutes.
In 3 minutes.
Determine the rate.
Determine the what? The rate
At which heat is given out.
Heat is what? Given out.
By the
heater. Now look at the question. They said what? An electric heater deep into 500 what? Gram of water in a plastic beaker. Raise the temperature from where? 20 degrees Celsius. Did they give us a specific capacity of water? Mercy did not send the word. 84200 joules per kilogram per Kelvin. It's supposed to give me specific capacity of water. That your question will be incomplete if it's not giving we are not giving that, because to us to determine the rates, anytime they talk about rate in physics, rate is what? Over time. Don't forget, rate is over time. Anytime you are giving rate in physics, if I say rate of work, it means work over time. Rate of momentum, it means momentum over time, which is force. Rate of displacement, it means what? Displacement over time. So if you say rate of velocity, it means velocity over time. If you say rate of what? Of momentum, I've talked about that is force. The rate of volume is flow rate. Is what? Then and so forth and so on. Rate of charge is what? Current. So if you talk about rate of work is power. So that means rate of heat is also power, which is what? Rate of heat, power, or rate of heat should be equal to what? Heat what? Energy divided by what? By time. So this is the formula to use for that question. Heat energy divided by time. What is the heat energy here? First of all, let's take our parameter. What is change in temperature? The change in temperature is what? 50 degrees Celsius minus 20 degrees Celsius. And that will give us what? 30 degrees Celsius. Now, what again I will give you the question? I told you, bring your data out. First thing, you take your data. The next thing is to choose a suitable formula. then you solve. So that one now, what is the time? Our time is 3 minutes. We convert to second, please. So 3 times 60. 60 seconds make 1 minute. So I would have 180 seconds. Very important you convert. Again, we are giving mass. What is our mass? 500 gram is the mass. So you convert with about 0.5 what? Kilogram. Now, what about what? The specific capacity is 4200 joules per kilogram per Kelvin. Now, the next thing is what? Let's solve our parameter. So, P will now be equal to what? Or rate of it will now be what? MC change the theta over time. So, this is the last one we're going to solve there for that person. So, we have tried. Another person should send their question so that 0.5 times what? C is what? 4200 times what is change in temperature is equals to what? 30. Divide by what? What is the time? 180. Because this time is them. So this one cancel here, we have 6. This one cancel here, we have 1. 30 divided by 180 is 6. Then what do you have? 6 here, 1. 6 here, 7. So 700. 0.5 times what? 700. You understand me now? So this one will now give us what? This one is simple as 5/10 times 700, which is the same thing as this one cancel about 350 what? Joules per second. And that should be what you are going to have. 350 joules per second. Do you have your own question that you want to ask? Please, if you have question, please send it across. Send it across. Don't just what? Be looking at us and listen. Send your question across. So that we can have benefits. Wave. Is it the calculation or the listen? Wave. Okay, wave. Wave is a very wide topic. So if I want to do wave, it's not something we can do just one night. So what I will do is that I will just create a video for wave for you so that you can just analyze a wave analysis for you. That means wave analysis, because wave is very, very broad, very broad. And it's wave from where you talk about sound wave, talk about light wave. From light wave, we link up to lenses, from mirror to optical instrument. So it's a very wide topic. It's not topic of 1 hour or 1 hour 15 minutes. Okay, under closed and open pipe. Okay, if you have, okay, we have what? This is what? Open pipe. I mean, like closed pipe. This is open pipe. Now, and this is string. I want to give you one shortcut there so that you can what? Now, these three, this is what? The closed pipe, open pipe, and strings. Now, what is the difference between the two of them? Let me differentiate. Now, for open pipe, it travel from antinode to another antinode. Now, this one travel from where? From node to what? Antinode. Then this one travel from where? Node to node. What is node? All this thing was brought from stationary wave. Look at the body. Look at it. A stationary wave is a wave that what? Have the same amplitude, the same frequency, and the same wavelength, and travel in opposite direction. So all of them, and this point is what we call the nodal point. The nodal point is a point where the wave has a zero displacement. While antinode is a point where the wave has what? And so I want to give you a shortcut formula now. Now, we know that frequency times lambda equal to velocity. Listen on. That means frequency equal to velocity over lambda. Now, most of the time, we work with length of the pipe. We work with what? Length of the pipe. And that is what? Let's say this is the length, L. Now, from node to what? To antinode, my dear. Node to antinode, take note of that, is lambda over 4. How? Do you know that from year to year is half Why from year to year is 1 lambda? You understand now? So from year to year is what? Half lambda. What about from here to this place? From the beginning to this place is what we call quarter lambda. So from node to what? Antinode. This is node, this antinode, this node, this antinode, this node. So from node to antinode is quarter. From node to node is half. Then from adjacent what? Antinode is what? Antinode to antinode is what? Lambda over 2. So antinode here is quarter, here is quarter. So from here to this place is quarter. This is lambda over 4. From here to here is quarter, lambda over 4. From here to this place. So from node to antinode quarter, from node to antinode quarter, that gives you the length of it. Now from node to node is 1 lambda. Node to node is a half lambda. Node to node is half lambda. Please take on that. Now, once you know that one, you are good to go. Now, this one now is lambda over 4. I want to drop the shortcut now so that I will now ask you a question. So, node to antinode is lambda over 4. I just told you before. Now, listen. Now, if what L length is equal to lambda over 4 for what? Closed pipe. About closed pipe. Please take note of this. Very important. Now, look at the word lambda over 4. Now, lambda equals to 4L. Class, will listen on. That means frequency, fundamental frequency. Fundamental frequency is the lowest or the first what frequency observed when the word is a particular pipe undergo resonance. So that means that what V over what 4L is the first frequency that will be produced by the word. Because I will put what in place of lambda, I'm going to put what 4L. So I'm putting what 4L here. This is for what? Fundamental frequency of what? Of closed what pipe. And a closed pipe is a pipe open at what? Traveling from node to what? Antinode. Open pipe is a pipe that travels from antinode to another antinode. That means there will be what? Open end. The two sides will be open. While closed pipe, one side will be closed, one side will be open. Then for this one, if here is lambda over 4 class, I want to look at lambda over 4 plus lambda over 4, making what? Half lambda. So that means that the length of a what? Open pipe is what? Lambda over 2. That means from here to this place is lambda over 2. Therefore, L equals to what? That means lambda equals to 2L. That means from length from here to this place is lambda over 4. From here to here is lambda over 4. From here to this place is lambda over 2. So lambda over 2 equal to the length of this word, first word pipe that will be experienced. You know that you cannot draw this diagram for the two ends to be open. The least length of the diagram you can draw is this one. So in that case now, or the largest length of the word that you can produce is what? Is that for this particular fundamental frequency. So what I would have now? Fundamental frequency will now be what? V over what is lambda? 2L. Now, the last part is what? Is also going to be the same thing with what? Fundamental frequency of sin is equal to what? V over 2L, because they have the same thing. From here to here is not lambda. So node and antinode is what? Lambda over 2. So now let's look at it now. If you do the next one, you are going to have what? 3 lambda, 3V over 4L. To try it, let me show you something. Look at it. I want to show you something before I drop the shortcut so that you know this man do Ojoro or this man just perform something that does not exist. Now, if I want to draw the next one, look at the board. Next one. Look at the board. This is the next one. Now, this next one is what? For the closed pipe. From here to here is lambda over 4. Don't forget to. Then from here to this node, not to know this lambda over 2. So class, what is now everything now? Everything now what? Quarter plus half is equal to what? 3/4. Abi? which is L. So what I would have now, 4L equals to what? 3 lambda. Let's make lambda the subject of formula. I want to have what? So that means lambda equals to what? 4L over 3. Now let me show you something here. The longest wavelength that can be produced by a closed pipe is what? At fundamental interval. That is to say, what I'm saying now is that how is fundamental interval related, frequency related to length? The length of a particular pipe, as it increases, what happens to frequency? Reduce. So frequency, fundamental frequency is the smallest frequency that a pipe can produce, but has the longest length that a pipe can produce. Please take note of that. In case they ask you, calculate the frequency of a closed pipe at its longest length. So you use this particular frequency. Now this one, now if you check, this one is what? 4L over 3L over 4L over 3. Can you compare it with this one? No, because this one is smaller than this one. Why? Why is the wavelength getting smaller? Because the frequency is is going up gradually. So what I want to do now, frequency, fundamental frequency, the next frequency, let me put it that way, will now be equal to what? V over lambda, which is what? V over 4L over 3. This one will go up as what? 3V over what? 4L. Now, what do you notice here? Something is appearing here. Check this one. Check this one. We see it here. So how do we write that one now? We can write it as F equals to what? 3 fundamental frequency. Now, if you continue to do it for this word, closed pipe, look at the shortcut here now. That means that closed pipe always have what? Odd numbers. The next one will not be what? 4 what? 5 what? F naught. The next one will not be what? 7 F naught. The next one will be what? 9 F naught. That means that, listen, I want to show you something now. Now, if they ask me, find the word. Now, 1, 3, 5, 7, 9, 11, 12, 13, and so forth and so on. Now, this one is what? The first harmonic, or the first fundamental frequency. The first fundamental frequency. This is the third fundamental frequency, which is third harmonic. Now, this one is what we call the 0 over 2. Hello, which is what? F naught. Look at the board. I want to show you. So this F naught. This is 3 F naught. That's how I wrote it. This is 5 F naught, 7 F naught, 9 F naught, 11 F naught, 13 F naught. So that means if the examiner asks you, find the third overtone or the sixth overtone of a closed pipe, what I will do is that this my overtone start from here. 1, 2, 3, 4, 5, 6. This is the sixth overtone. So I will now write it as what? The sixth overtone is equal to what? 3V over 4L. The sixth overtone. Sixth overtone is what? 3V over what? 4L. 13V over 4L. How do I get it? Just what? Don't forget that closed pipe are odd numbers starting from 1. So 1, 2, 3, 4, 5, 6. So I will have the. But if they ask me for wavelengths, look at the manipulation of wavelength. From this formula, I can get my wavelength. I don't need to go through all this one. If you are drawing diagram in this Jamb, you will waste all your time. So what I'm going to do, my wavelength will now be 4L. This 4L divided by what? 13. So now, what will not be my word? If I ask you for length, length will not be equal to what? 13 lambda over 4. It's very easy to find length. Now, that means I'm telling you that from this shortcut formula, you can get your length, you can get your wavelength. For instance, let me answer a difficult question. Can you give me the length of a 10th overtone? 10th overtone of a closed pipe. We are solved. 10th overtone of a closed pipe. Let me see what I want to get. start to send messages. 10/2 of a closed pipe. I'm talking about closed pipe now. 10/2. Don't draw diagram. Don't do anything. Just give the answer. You can do normal write up, but don't draw pipe. Don't deceive yourself. Do it straight. Write the number out and do the 10/2 for me. 10/2. 10/2. I've gotten my own answer already, even without drawing diagram. So what you should be expecting? What should be your answer? F will not be what? 21 what? V over what? 4L. 4L. That is frequency. What about the length? I mean the lambda, the wavelength. 4L over what? 21. Then what is your length, class? The length of the what? 21. That means this one will come here. 21 lambda over what? Over 4. Now, how do they get it? Let's look at it. Let's look at it. Now, I say this one is 0/2. 0/2. This is what? The first, the second over 2, the third, the fourth, the fifth, and the 6/2. But this one is third, fifth harmonic, fifth fundamental frequency of fifth harmonic, seventh harmonic, ninth harmonic, 11th harmonic, and what? 13th harmonic. So that is it. So, or 13th fundamental frequency. Then what I would have, that's 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21. I'll stop there. Now, this is the first, look at it, the first over 2, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10. So the 10/2 will carry 21 here. You understand now? 21 here. Why the what? When this one is 21, then 21 V over 4L normally must be V over 4L, which is fundamental frequency now. So now from there, you now say the wavelength will now be what? Don't forget that if I carry this 21 down, V over lambda, this one represent lambda like this. Hello, frequency equal to velocity over lambda. Have you forgot it? So if I can bring mathematics, permit me to bring this 21 from here and bring it down. So everything you are seeing here is what? Is what? Lambda. So that means that lambda equals to 4L over 21. My length will not be what? 21 lambda over 4. So you have actually proved that question. Now that is for all what? Closed pipe. So closed pipe now, what I will advise you, closed pipe is odd number. Closed pipe, odd number. Why what? Open pipe and strings are natural number. Open pipe and strings. Let me show you now. Strings and open pipe, they have the same thing. Look at the board. The next one will be this one. Before I show you the shortcut. Now, this is open pipe. Must be open at both ends. You cannot stop it here. Because if you stop it here, you are going to have the initial one. So we have to do it further. This one is what? Lambda over 4. From here to here is what? From here to here is what? So everything here is what? Lambda what? This quarter plus quarter is half. Plus half is what? 1 lambda. So that means from here to this place is 1 lambda for this pipe. Now, I haven't known this now as 1 lambda. Now, what do we do now? Our L is now lambda. Then we are going to have frequency is equal to velocity over lambda. And that means frequency will not be equal to V over, you replace what? Lambda with L. I would have. Do you know that I want to write it to favor what I have written before? Do you know I can write this one as what? Class. This is the answer. But I want to write it so that this one can show. I can write it as what? 2V over 2L. Do you agree? Yeah, it's the same thing. No? So that I can show you fundamentally that something is showing there. Look at it. The fundamental frequency of what? Of what? This one is for what? For open pipe. Abi? Open pipe now. I show you. This is for open pipe now. And this one is for what? Closed pipe that we have just talked about. So in that case now, fundamental frequency, then this one is for strings. Strings, which is the same thing with what? This open pipe. Now this one, what do you notice now? This one is two fundamental what? Frequency. So if you continue to do the third one, if you open it, you are going to have 3F0. Fourth one, 4F0. So therefore, if you want to do what? For that of what? What do you call it? For open pipe and strings, look at it. Their what? Their number is 1, 2, 3, 4, 5, 6, and so forth and so on. That means that they have fundamental frequency of what? V over 2L. The next one is what? 2V over 2L. The next one is what? 3V over 2L. The next one is what? 4V over 2L. The next one is what? 5V over 2L. The next one is what? 6V over 2L. So that's what we are going to have. Now, instead of being that, if I now ask you, this one is what? The first what? This is 2F now, F0, 3F0, 4F0, 5F0, 6F0. So this one is the what? The first over 2. This is second over 2. This is what? The third what? Over 2. And so forth and so on. But I want to show you something now. What do you notice about the relationship between over 2 and the value for what? F0. You notice that when it was third over 2, here was 4. So if I now ask you, what is the frequency for what? Frequency of 100 over 2. Frequency of what? 100 over 2. 100 over 2. The frequency of 100 over 2 will be what? Will be what? Will not be that over 200 over 2. When there will be, when it was third over 2, it was here was 4. When it was second over 2, here was 3. So 100 over 2 will not be what? 101 V over what? 2L. This is what? For 100 what? 100 over 2. If I ask you for what? 6 over 2. 6 over 2 is what? 7 what? V over 2L. And this formula applies to both what? Strings and what? An open pipe. Please take note of that. So you can send questions so that we can apply it to what? To this. I've explained it for you quickly because that one is more or less like formula. So it's not something that will take time. So ask questions. Have anybody sent question?
Someone said, what's the function of wave?
The
Function of wave.
function of wave. Wave. I don't understand that question. Function of wave. Function of wave. Wave is used to actually what? Analyze what? The wave nature of matter. Wave nature of matter, because there are two branches majorly in physics. We have the one that particle aspect and we have the wave nature aspect. So the function of wave, okay, let me say the function of wave, according to its definition, is to transfer energy from one point to another. That is number one. The function of wave. What is wave? If you have a wave, is what? Is a disturbance that transfer energy from one place to another. So I can see a wave as an energy, as an energy transmitted what? Medium. That means that transfer energy from one place to another without what? The intervening medium. So what function of wave? I can tell you that majorly wave helps to transfer energy from one point to another. So that is basically what I would say concerning function of wave. But if you have a different opinion, you can type it and send it to the group. But from the basic knowledge, basic concept of wave, that what is function, when they say what is function, what is your work? You understand? If they say what is the function of Mr. Haliday, it means that what is its what doings, what is its what what is my importance, relevance, functions. So when we say function of wave, basically I would say it helps to what? to transfer energy from one point to another. So if you have any question again, please send. But there is one question on what? On projectile that Jamb actually solved wrongly that I want to tell us before somebody will send question. It is not normal projectile question, please. That one is not normal projectile question that people always know that is regular. But when they said that question, I was so shocked since we are still waiting for question to come. If there is no question, please, I will end the class. That's why I'm waiting for you to ask question. If there's nobody to ask question that will make the class continue, then we'll end the class because I don't want to bore the students. I told you I'm not setting my own question. It is question of the student and Mr. Haliday. Now look at the board. If we have set a question like this, now look at the board. I want to give you a very shortcut method to solve this question. Either like this now, look at the board. They give you what? Probably they give you what? Let's say 20 meter. 20 meter. And a body is projected with a velocity, let's say velocity of, let's say, what velocity can we use? Let's say we use velocity of, let's say 20 meter per second. Now, then I say calculate the time of flight from here to here. Time of flight. Calculate the time of flight from this point to this point. This question is very common in Jamb. Some people will go and use this one. T equal to 2 over G. You have failed it now. It's not correct. It's not correct anywhere on this planet. It's not correct. Because this formula can only be used for what? When the body what? Look at it. It's a two different case. When it was projected from the ground and landed at the ground level. The time to go up is the same time to come down. That is a case of this one. In this case now, the initial height of projection is 0. The final height of projection is what? 0 meter. Now, don't forget that this one now, the level of projection is the same. So as such, the time it will take to go up, the same time is what they could come down. So the time of flight is equal to 2t, which is equal as 2u over g. Because t is time to reach maximum height, and time to reach maximum height is what? U over g. Now, this one is different from this. This one now, listen very well and listen so good. The initial height, the body was thrown from a particular tower, is equal to what? The initial height here is equal to 20 meter. 20 meter. Then the final height is where he landed. Don't forget, there is a very important point you should know. When a body is moved, is thrown upward, it's being displaced. So S equal to what? UT minus what? Half GT squared. This is not distance, it's displacement. A displacement is that what quantity that have initial and final what distance. A displacement is different from distance. It has initial and final what distance in a specific direction. So that is to say, displacement, this formula should be what? H naught, H1 minus H naught. It is what? UT minus what? So anytime a body is being displaced upward, what do we use here? We use minus. Why do we use minus? Because it's going against gravity. Now, for this question, if you want to solve this question now look at the board. H1 is what? 0. Why is H1 0? Because the body is what? Displaced what? It comes down. The final height of the body is on the ground. What about the initial height where the body was projected is what? 20. Equal to what? What is your U? U is equal to what? 20 times what? What is the time? You don't know it. Minus. Why are you using minus? Because the body is projected. When the body is projected against gravity, it's minus. Half times what? 10 times what? T squared. Now, what do we have? Now, we are going to solve this one. Now, we are going to have what? Minus 20 equals to what? 20t minus 5t squared. Recall that this one is what? 2 year 1, 2 year 5. So we're going to have this one as what? 5t squared. Collect like 10 minus t minus what? 20. So this one, if you divide all through by what? By, let's say we divide all through by what? 5. What do you have? If you divide all through by 5, what do you have? You would have t squared minus 4t minus what? 4 equal to what? 0. Now, it has turned to quadratic equation. But this quadratic equation, we now solve it with what? Minus b plus or minus square root of what? B squared minus 4ac over 2a. Now, that's what we are going to solve it with. Now, that is what we are going to solve it. So, what we are going to have now is what? B is what? Minus 4. And C is equal to what? Is equal to 0. Sorry. A is equal to what? 1. Then what about C? C saying now we have substituted what? This is initial height, which is what? 20. Final height is what? 0. So what we did now is that we now what? Substitute 20 initially projected with what? Initial velocity of what? 20, which is what? Times t minus half times 10 times what? T squared. So this one we cancel here, we now have 5. That's how we get that one. That 5 there. Then G is equals to what? 10. They give us G as 10. So when you do it now, you have this. You have this. Then collect like terms, which is what? This one will come here plus 5. Then this one will come here minus 20t plus 5t squared minus 20t minus 20. Then the Bible side by what? By 5. I would have t squared minus 4t minus 4 equal to 0. So that's what we are going to have. Now we solve it quadratically, we are going to have this. Now, what is square root of 32? Now, without calculator, those of you that are writing down, without calculator, you can find the square root of 32 with ease. Now, what perfect number is close to 32? It's what? 25. 25 is close to 32 without calculator. Then the square root of 25 is what? 5 plus. Now, 32 minus what? 25. We are going to have it as 7. Then 2 times, that means you are going to find a perfect number close to 32, but not greater. A perfect number. 25 is a perfect number, perfect square number. So if you would find square root of 25 is 5. You now say 32 minus 25 is what? 7. Divide by what? Now, 5 times 5, 5 times 2 rather. This one multiply this one by 2. What do you have? 10. So our answer should be what? 5 point what? Plus 0.7 is what? 5.7 for that one. So if you press the calculator, you would have 5.7. So 4 plus or minus 5.7 divided by 2. Now, our answer, I will not use minus. You know why I will not use minus? 4 minus 5.7 is what? Minus 1.7, which is not possible for time to be negative. So I will throw that one away. What I will use now, my time, because if I use minus, I will have what? Look at what I'm saying. If I use minus now, I will have what? 4 minus 5.7 divided by 2 and 4 plus 5.7 divided by 2. Those are the two times I'm going to have. This one will give me 1.7. 1.7 divided by 2 is what? 0 minus 0.7 seconds. Press your calculator. But if we divide by 4 plus what? 5.7 is 9.7. And 9.7 divided by what? 2 will give us what? 4.3 what? 5. This is what? 4.35 seconds. And this one will be the time, because it is not possible for time to be negative. So time will always be positive. So this one will not be what? 4.85. Okay, 85. I think what? 85. So that will not be our answer for that one. So your time of flight from year to year is 4.85 seconds. Why the other one is negative, so you throw it away, because time cannot be negative. Any question there?
Yes.
Somebody say a question. Okay.
A pipe closed at one end.
A pipe closed at what? One end. This is a pipe. A pipe closed at one end is closed what? Pipe. A pipe closed at what? At one end.
Has fundamental frequency of 200 Hz.
Let me clean the board where a pipe closed at one end has a fundamental what? Frequency of 200 Hz.
The frequency of the first over 2.
The frequency of the what?
The
First over 2
of the closed pipe.
of the closed pipe.
Is equal to the frequency of the first over 2.
The frequency of closed first what? The frequency of first over 2 of the closed pipe is equal to what?
To the frequency of the first over 2.
To the frequency of the what?
First over 2.
First over 2 of what?
An open pipe.
Of an open pipe. Yes?
Find the fundamental frequency.
Find the what? The fundamental what? Frequency. Now look at the board. Now, let me clean this side. Now look at the board. They say a closed pipe. A closed what? A pipe closed at one end. So one of them is closed at one end. Then what is it? After closing at one end, what is it? It is lambda over 4. So the frequency of the length is what? I prove it there. The fundamental frequency of this one is V over 4L normal. And as the fundamental frequency of what the fundamental frequency is 200 what? Hz. Is 200 Hz.
So the question is not finished.
The question is not correct.
It's not finished.
Okay.
If I find the fundamental frequency of the open pipe
Of the open pipe. Okay.
and the length of the closed pipe.
And the what?
The length of the closed pipe.
Okay. The question is, and the what? The length of the closed pipe. Thank you for the question. Now let's our people learn from it. You understand me now? Now let's see how we go about the question. Now the first thing I started with was, they say open at one end, class seat. Open at one end. Now what I did now was that since you open at one end, the frequency, the length is equal to what? lambda over 4. And if you work it out like following our proof, you notice that what I told you, the length is, we cannot calculate the length from here because we are giving fundamental frequency of the open pipe, of closed pipe to 200. So let's first of all calculate the length first of the what? Closed pipe, because we need to calculate the length. Now, why we have to calculate the length? Because they say find the what? The fundamental frequency of the open pipe and the what? The length of the closed pipe. And they said what? A pipe is closed at one end and has a fundamental frequency. So that means the frequency of this one now is what? It's already 200 equal to what? V over what? 4L. So let's call this one equation 1. Leave it there. Now, let's call the what? Global. They say the first over 2 of closed pipe. What is first over 2? First over 2 is 1, 3, 3. Now I give you a shortcut now. First over 2 is 3. Second over 2 is 5 of closed pipe. So 3V over 4L is equal to the frequency of what? Of the what? First over 2. If I give you third over 2 will be what? 7V over 4L for a closed pipe. Don't forget to. If I give you what? The fourth over 2 will be 1, 2, 3, 4 is 9V over 4L. So first over 2 is this. And then that's equal to the what? To the first over 2 of the what? Of the open pipe. So first over 2 of the open pipe. What is first over 2? Let's say this length is what? Length of the what? Closed pipe. Let's call it C. L subscript C. Then let's say what? Is equal to what? Open pipe. What is the first over 2 of the what? Open pipe is what? 2V over 2L. Don't forget to. For closed open pipe is what? 1, 2, 3, 4, 5, 6, and so on. Natural numbers. And the first over 2 is 2V over 2L. This is what? Open pipe. Now, recall, this is closed pipe, don't forget. Recall that what? Hello, listen. I can make what? 4L the subject of formula here. Remember, I can make 4L the subject of formula. If I do that, what am I going to have now? That V over 200. Is not true? Yes, V over 200 now. So we can now what? Work without that one. So we can say 3V over what? We can even cancel out. Let's cancel out. Because velocity of light in air is also the same thing. They have the same velocity. So when the velocity of sound in air is what is called V. So we can cancel out. What do you have? You have 6 what? This times is what? 6 what? L open equal to 8L close. Is not true? Now, look at the board though. Now, what do we do now? We have got it down. Now they say what? Find the fundamental frequency of the open pipe. Now, first of all, we need to get our what? C and L. Now, they gave us 200 as the fundamental frequency. So if we cross multiply, what do you have as our V? First of all, what do you have as our V? So we have from equation 1, let's call this one equation 2. So from equation 1 now, if you cross multiply, I would have a V equals to what? 800 what? LC. 800 LC. That is our view. Now, if you have 800 LC, closed pipe, this is closed pipe, this is open pipe, this is closed pipe. Now, what did they say we should find? Find the fundamental frequency of the what? Open pipe. Now, listen and listen so good now. There is a relationship between frequency, fundamental frequency, and the what? The second word. Because the second one, look at the word. The second word, fundamental frequency, look at the word. This is the first over 2 of the closed pipe. If the first one is what? 200 class. For closed pipe. What is it? What? First over 2. First over 2 will be 3F naught. I hope you know. Which should now be 600 what? 600, you know 600 hence. That is first over 2. That's what it means. Because if what? They say what? The frequency of the what? Of the first over 2 of a closed pipe is equal to what? That means 600 eh, is equal to what? That means 600 actually is equal to what? Is equal to the first over 2, which is what? V over what? That means 2V over what? 2 what? LC. That is it now. Now, look at the board now. We have made it very clear and very easy. What is our what? Our this open pipe, not close. So now we have made it very easy. So this one will cancel out this. Then we are going to have what? 600 equal to V over L naught. Now don't forget that what I did was that frequency of the what? Of first over 2 of the closed pipe. They're giving us fundamental frequency of the what? Of the closed pipe. So first over 2 is 3F naught. So which is 3 times 200, which is 600. Now, they're not saying that first over 2 is equal to the fundamental frequency of the what? Of the what? Open what? Of the overtune of the what? First overtune of the what? Of the of an open pipe. Now, first overtune, this is what? The first overtune is what? Fundamental frequency is 2L. First overtune is what? 2V over 2L. And which I have done here. So if that is your what? Your 2V over 2L is your what? First over 2. That's why I equate it to be what? To be that. Now, velocity of light in air is supposed to be given to us. If they do not give us, then you can now use as what? 340 over L naught. They want to give us, I don't know the person that gave that question, want to give us velocity of sound in air. That's what they are, is constant. It's 340. Sometimes they use 320. If you do that, you are going to have what? What I would have? 6 L naught equals to what? 340 divided by 600. A lot of sound in air is constant. So what do we have? We are going to have what? Or open pipe. So we are going to length of open pipe. Open is what? L naught. Close is what? C. You understand now? So velocity we are reducing now. We are looking for the length of open pipe first. Then when we solve it, we can now bring it here. Look at it. Open pipe now. If I put it here, I will get what? Length of what? Closed pipe. I cannot put it here to get what? Whatever fundamental frequency they want us to calculate. So that is just that. So this one give us what? This one cancel this one. The only thing missing in the question that is making my time to take my time is what? The person did not give us the velocity of speed of sound in air. It's constant. It's supposed to give us the speed of sound in air. They will give us is 340 meter per second. It's constant parameter. Because if you don't give me velocity of sound here, that means I'm going to be looking for 3 unknown. It's not possible. So maybe the person that sent the question should be able to testify to that. The velocity of speed of sound in air should be given. If it's given to us, then we can now what? Then this will give us what? 34 over 60. What do you have? Press the calculator for me. Then if I get that one, I can get this one now. Don't forget, I'm related. 567 meter. Then or centimeter, depending on how what unit. Okay, meter, because I'm using velocity of sound in it. Then for L naught is what? For open pipe length. Don't forget. Then LC is what? Close what? Pipe, so that you don't miss it. Close pipe length. So what we are looking for length of the closed pipe now. So the closed pipe will now be what? LC equals to what class? 6L naught over what? Over 8. Please, when you are giving me a question, ensure the question is complete, because if it's not complete, it will make us to be having as if we don't know what we are doing here. Very important, you let us know. The speed of sound in air should be given. It's constant, just like when you are giving me a question without G. So that will give me what? 6 times what? 0.567 divided by 8. What do we have? We are going to have it as what? 0.425 meter. So this one is length of the closed pipe. Then what they say we should find again? The fundamental frequency of the what? Open pipe. Don't forget that fundamental frequency of open pipe is what? V over 2L. Open and put what? 0. So I will not mix it up. This is fundamental frequency of open pipe. I will now use what? 340 divide by what? 2 times. What is our length that we have calculated for open pipe now? 0.567. So what will now be our answer? If you not have taken my time like this, please ensure you give us length of every parameter complete. If you don't give me parameter complete, there is nothing I can do. I cannot manufacture value from anywhere. Yes? 299.8, which is approximately what? It's approximately what? Let's say 300 what? Pence. So that is what? The value for what? The fundamental frequency of what? Of open pipe. Open pipe. So if the person is satisfied with the solution, just send us what? Thumb up message to show that you are okay with it. So
sir, is T equals to T in a 2U over G valid for non-uniform motion?
T equals to what? 2U over G valid for. Now, don't forget this one is vertical motion. Vertical motion are uniform acceleration motion. Don't forget to. So when you say uniform motion, you should specify. Now, it's talking about vertical motion. And vertical motion, your acceleration is constant. I'm not talking about linear motion. And this is not formula, but in as much you are seeing G here, you understand? So, uniform motion, where we are talking about here, is not normal kind of. It's motion with uniform acceleration along the vertical. So this one now is only valid this 2U over G is valid for what? When a body starts from the ground and hits the ground level back. It's projected from the ground level and come back to the ground level. So in that case, the time to go up is the same time to come down. So the time of flight for such object is equal to 2U over G. If it's projectile at an angle, it's what? 2U sin theta over G. Don't forget, if it's projectile, that angle will be given is 2U sin theta over G. Why the time to go up? If it projected at an angle like this, for example, look at the board. Let's say it project at an angle like this to the horizontal at an angle theta. You understand? The time of flight from here, from level of projection back to the level of projection will be 2U sin theta over G. Yes? Any question so that we can answer?
Two thermoflask of volume.
2 thermoflask of volume. I'm coming, let me clean the board. 2 thermoflask of volume. 2 what? Thermoflask of volume.
Vx and Vy.
Vs and what? And Vy.
Are filled with liquid water.
Are filled with what? With liquid water.
At an initial temperature of 0 degrees Celsius.
At an initial temperature of what?
0 degrees Celsius.
0 degrees Celsius. At an initial temperature of what? 0 degrees Celsius. Yes?
After some time.
Yes?
The temperature were found to be theta x and theta y respectively.
The temperature were found to be what?
To be theta x and theta y.
To be theta x and what? Theta y respectively. Yes?
Given that Vx
Given that what?
Vx over Vy
Vs over Vy
is equal to
is equal to
2.
2.
And theta x over theta y
Theta s over theta y.
equals 1 over 2.
Uh-huh.
The ratio of the heat flow in the flask is
The ratio of each flow in the plastic is what? In the flask.
is
The ratio of each flow in the flask is. Now look at the board. Look at the board. Now this, we are talking about what? 2 flasks of volume are filled with liquid water at what? Initial temperature of that. After some time, the temperature of their two is what? Is what? Found to be what? This. Now, they say reflectively. And I say what? Let's see. First of all, the heat flow formula, heat flow is equal to what? MC change in temperature, or MC, yes, change in temperature. Let me leave it like that. Because water is heat, so we leave it like that. Don't forget the 2 flasks are filled with water. So the same liquid water. So over time. So, but this one now, they did not say rate of heat, so we just leave it like this. Recall that mass is equal to what? Density times volume. Mass is equal to what? Density times volume. Don't forget. So therefore, I can write heat flow equal to what? Density times volume times C of water times change in temperature. That is the formula I want to apply. Now, this formula is not too common. Many of you, don't forget your formula that density equal to mass over what? Over volume. Don't forget. Very important. Now, if you now know that, very important. Now, I can now say that what? They said what? The 2 flasks of heat, VL and VY, are filled with liquid at what? This other. The temperature where now, we are going to assume, because the density of the 2 of them are the same. The density of the 2 of them are the same. That means that H equals to what? V C of water times theta is equal to density. Why? Because it is the same water that is being used. So the density of water, of the liquid, is the same. It's standard. What is density of water? The density of water is 1,000 what? Kilogram per meter cube. Now, but the heat flow, the ratio of their heat flow, we don't know it. So let's call this one for S. Let's call this one what? Look at it. I want to call this one S. S. This one now. Okay, let me leave the water S, because the density of water. Then the density of water is constant. It is different. This one is different entirely. So their heat flow will be different because they are operating at different volume. Don't forget, even if you supply the same heat to them, the heat flow will be different because they have different volume of water. Just like having small cup of water, you apply it to it. I have a volume, a big bowl of water. If you apply it to it, the way this one will change the temperature is not different. It's different from the way that small water, the one in a container. Let's see, look at this. Look at what I'm saying. If I have something like water like this inside the container, look at it. So I have water like this inside this container. I have another one here. You cannot tell me that these 2 will have the same heat flow because their volume is different. In fact, they cannot even boil at the same time. Though they will boil at 100 degrees Celsius, but this one will take time than this one because of the volume. So volume can affect the rate at which what the heat will spread. Now look at the board. So density is the same. So I will now say heat of Y over Vy times specific capacity times theta Y. This is the formula I want to use now. So density is constant for the 2 of them. So I will just equate this and will solve. Don't forget, I can cancel this one. This one can cancel this one. While specific capacity of water for both sides can be cancelled. Why? Because the 2 of them are made of water. It shall not be affected by it. The specific capacity of water cannot change from 4,200 to 8,200 because it remains constant. it remains constant. So H equal to what? Vs times theta s equals to what? Hy over what? Vy and theta what? Y. Now, but take note of something. They've given us theta x to theta y and they're giving us volume. So we are looking for h now. So let's divide what? Which one do we divide? Let's divide hy over hs over hy. Now, before we do that, let's cross multiply first so that we can see better. If you cross multiply, what do you have? Now, what have it as what? Hs Vy theta y equal to what? Hy Vs theta s. I mean, Vy theta y Hs is equal to what? Vs theta s Hy. Now, what do we do to divide both sides now? We divide both sides by what? I want this one to live here, this one to live here, and this one to live here. I want these two to go under this one. And I want this Hy to come under here. So what do I do now to do that? I will divide by 3 of them. I don't want this one here. I don't want this one also here. I don't want this one here. So what do we do? Divide all 2 by 3 of them. Let them leave their various position. Vy theta y over what? H what? Y Vy theta y. So what do we have? This one will cancel. This one will cancel. So what we have, what you cancel again? So what do we have now? Finally, we can now solve what is in this there? Hx over what? Equal to what? Vs over Vy times what? Theta s over theta y. So what the final answer now there? What is Vs over Vy? We are giving as 2. This one is given as 2 times. What is the one theta x over theta y? What do you have? 1 over 2. I mean, so this one cancels. What I would have? 1. Is 1 there in the option? Yes, that is the answer to that question that you just gave to me now. So that question was brought by one of our students in class. So to solve it. So now, so if you have any question, you can send your own question across to it. You can send your question across. You can send your question across to us so that we can solve. But I don't think we have more time because if you cannot answer to us quickly, we don't think we have more time again. So since there is absence of question, I think we need to go and rest. Tomorrow again is another section, which is day 2 of this class. So that we want to leave you now so that you can go and read your book. And if you have other things to do, you can go and do it. For day 2 tomorrow, ensure you subscribe and tell somebody about this class so that we can enjoy more of this class. Please help us share this video, help us tell someone about it so that we can we can have more encouragement to do more. So please ensure you go through our question. Ensure you go through our question. Ensure you go through our question. I just sent some questions, some Jamb questions that have just been sent to us. You understand now? Some likely examination question rather. Likely examination question. You understand?
Somebody just sent a question.
Oh, you see somebody just sent a question again. Okay, let's see.
A person with maximum distance of vision 10 centimeters.
A person with what? Maximum what? What?
Distance of vision.
What time are we having now? What is time now?
10
Okay, 10:31. Maximum what? Distance of what? Of vision is what?
centimeters.
10 centimeter.
Uses a diverging length of focal length 15 centimeters.
Uses what? A diverging what? Length of what?
Focal length 15 centimeters.
Focal length of what? 15 centimeter.
as a magnifying glass.
As a what? A magnifying glass. Uh-huh.
Glass. What is the magnification when the lens is held close to the eye?
It's close to the eye. What is what? The magnification. So that is what you are saying now is what? What they uses a what? A diverging lens. The person have come change this question. You understand me now? This one now, you cannot have a diverging lens and use as what? As a magnifying glass. This question should be what? A converging lens. You don't use diverging lens for, I don't know where, what, you don't change question anyhow. Just to achieve your aim. This question should be what? A converging lens. We use converging lens for magnifying glass. Cases we have used it for is what? We use it for compound microscope where it has as eyepiece lens to improve simple microscope, which is what using one convex lens. Convex lens or converging lens. Using diverging lens is even a class because this is a YouTube class that people are seeing from different various places, various countries. So you cannot use a diverging lens as a man because the image formed by a diverging lens, look at it now. The image form, don't maneuver questions, please. We are not here to show that we are better than anyone. We are here to what? To touch lives. Now look at the board. If you put an object here, look at the board. Look at what will happen. Look at it. The image. Look at it. Look at this thing. The image form will be diminished, will be erect, and will be virtual. That means virtual, erect, and diminished. That is the image form by a what? A diverging lens. So a diverging lens can never produce a what? A what? A magnifying what? You understand? Image. It cannot. So it's always what? Virtual, erect, and diminish. So please take note of this question and give us the right question. Don't change anything. Don't. Some of us, what the problem we have about this question is that when we give if a case we give a question or we have a material, a PDF material or a journal that gave a question, don't change it. Use the question like that. If you use the question like that now, you can now say, okay, we can draw the diagram. But what I want to do was to draw the diagram of this particular question and analyze it. But the way you gave me now, I cannot draw the diagram of this question and show and analyze it because it cannot be used as a. Don't forget the image formed by a converging diverging lens, which is what we call concave lens, is virtual, erect, and diminished. It is virtual, erect, and diminished. You understand that? So you cannot use it for what? As a magnifying glass. It's not possible. I've not heard before. So please, just what? Correct your question and send it to us so that we can solve. It is not a class where we use want to impress anybody. So please, it's a class to help students. If you have adjusted the class, you can send me message on my WhatsApp. Send message on my WhatsApp, which was 081-333-55411. You can send your question there to us and send the right question, please. Somebody gave us a question recently and did not give us speed of sound in air. We cannot solve without speed of sound in air. Maybe the question did not give you speed of, maybe it's not your fault, but there must be a speed of sound in air given to us in the question when you are talking about sound wave. Because without speed of sound in air, there will not be vibration. There will not be frequency because we cannot solve frequency or solve length without speed of sound in air. So that one is settled. So my name is Engineer Haliday, and I believe that you have enjoyed the class. So we want to call it a day now. So tomorrow, if you have any question, we are coming here today, tomorrow for day 2 of this class. Ensure you will subscribe and ask question tomorrow. We want to go and rest now. Tomorrow we come back again for more questions and answer. Please don't forge question. Don't change anything from a question in order to say, okay, this man you want to make this man fail a question or not. No. Don't try to do that because we will notice every question have their practical understanding. There's no question you want to give us now that doesn't have a practical. Physics is practical. So it has a practical foundation or background. And that's what we are seeing. Thank you very much. God bless you.